Hello, today I'll show you how to use Bezier curves to interpolate points in LabVIEW. A Bezier curve is a parametric curve often used in computer graphics, named after the French engineer Pierre Bezier, who used it to design cars. In scientific computing, we often need to plot a line that passes through a set of prescribed control points or nodes. Spline is a collection of polygonal segments. The segments can be linear, quadratic, cubic, or even higher order polynomials. Today I will use a cubic Bezier polynomial. Wikipedia has a very good article on Bezier curves, which includes an animation showing how these polynomials work. Also, for example, with a simple regular spline, smoothly connect points for which multivalued correspondence of x and y is not possible. First, I will show some equations and then show the code and examples. So, in this definition of this curve, points P0 and P3 correspond to our points, nodes. The other 2 points, P1 and P2, are control points that define the shape of curve. The curve doesn't pass through P1 and P2 points. We also want the first and the second derivatives to be continuous across the spline boundary. This will give us 2 equations, one for each derivative on each spline interface that we use to find control points. Also, we denote by k the same our point included in 2 segments. Equations 1 and 2 for second derivative are defined only at internal nodes, places where 2 segments converge. Mathematically, this means that we have 2 n-1 equations for 2 n unknowns. To close the system, we prescribe 2 more natural boundary conditions. In other words, the spline becomes linear at endpoints. These 2 remaining equations, 3 and 4. We also can further simplify the system, substituting equation 1 into 2 and get this one. And all the system is a triagonal system, 3-diagonal system for P1, which we can solve easily. Once we define P1, we get P2 from equations 1 and 4. Now I will show examples and at the end the code of the program. Large dark blue points are the starting points to be connected. Small red dots are P1. Small green dots are P2. I note that P1 and P2 must be equidistant from our point, and also line the same line with it. The blue curve is Bezier interpolations, and red curve will be interpolation with the usual cubic spline, which is in the LabVIEW palette. So in this example, you can see that a regular spline connects points from left to right, not how we want. Pay attention to this place. The spread is not that big. In this case, the results are similar. In this case, the curve does not pass through this point at all. For example, an oval, you can't connect smoothly with a regular spline. Now I will show some examples of pulses. In the beginning there are only 6 points that an ordinary cubic spline cannot connect. Increase the number of points, more points, so this. So for some applications I think interpolation by Bezier curves may be useful. Now I will show the program code. It is small and simple. This is data set I showed before. They are switched in the form of 3-dimensional array with a button here. Just increase the array element by 1. This part implements the standard cubic spline interpolation. These two subroutines are not interesting. In this one, the desired dataset is selected. In this one, an array of x is created for interpolation for this function. So this part implements Bezier interpolation. So if you want to use it in your code, just copy this part. First, in this function, I create the matrix of this kind for the subsequent calculation of P1 coefficient. So I create this matrix. In this one, I calculate the x and y vectors for P1 matrix, and specifically the right parts of this. Then the matrices are solved, and we get a set of points P1. Points P2 are easily calculated from points P1 by these equations. And the last one, since we have everything calculated for each segment, we mark 1000 points on it with equal intervals and build Bezier curve. So that is all. Under the video there is a link to GitHub. There is a program. In the folders there are a couple of articles. And thanks for watching. Please ask me if something is unclear.